All right, so I highly recommend all of you follow along, and a good way to do that is just with snippets in Chrome. So if you want to go to a blank page, you don't have to, but you can copy what I've got in my URL bar here. And then when you do that, open Developer Tools, go to Sources, and Snippets. It might be hidden under this this double arrow. And that'll let us just type things into the browser and run it. Let's see, memo. Say again? Nah, it doesn't. I like to do a blank page so that I can mess with it without other noise, but I don't think we'll be doing much of that today. All right, so we're going to talk about memoization, or we're going to be talking about a technique of using, of just embedding a function inside of a function that can be used for memoization, as well as a bunch of other things like debouncing, or there's a few things in Lodash like once, or that kind of a thing. And okay, so let's start. Copy this kind of scaffolding, and we'll walk through it. So the end result, the thing that we're trying to arrive at, is something like this. My memoed function is equal to, oops, some memo function, and then my function, right? So we've got some function that we want to memoize. So we're going to pass that to another function called memo, and we're going to get back a memoized version of our function. That's the end goal. You don't have to do this pattern. You can just kind of manually memoize a function if you don't need a reusable version of this. We'll use a reusable version of it today, but just keep in mind you don't have to. So what we're going to do is we're going to create a function called memo, and it's going to take the function that we're passing into it as its only argument, and so we're passing a function in, and we're returning a function. So my memoed function is the function that we're returning. So we need to return a function. Okay, this function is going to take something. We'll talk about that in a minute. And then it's going to do something. So when we get our memoized function back, to back up, we talked about memoization briefly last week, but does anybody kind of just need a quick overview of what memoization is? Memoization is, thanks for asking, sorry, I'm jumping ahead of myself. Memoization is, it's a way to, the technique we're going to be talking about is a way to intercept the arguments that are passed to a function, or to intercept the return value from this inner function, this my function here, so that we can do something before we call that function, or after we call that function, or before and after. Maybe we want to modify the arguments. Maybe we want to save the arguments. Maybe we want to modify the return value. It's pretty open-ended. Memoization specifically is saving a computation. It's trading CPU time for memory. So if you call a function that is expensive and you memoize it, then it saves the return value for those arguments. So the next time you call that function with those same arguments, it's already got a saved return value for that. So it just returns its cached value immediately, so you don't have to do the computation again. So this comes up a lot in examples in like the Fibonacci sequence, where the computation is expensive, but if you cache it, then it becomes really, really fast. So that's what we're going to be doing. We're going to save the arguments that are passed into our function and cache those arguments. So all right. So as you can see, we're returning some function, and the function that we're returning is the one that we're saving here, my memoed function, which means my memoed function and my function should be semantically identical. We're going to call it with the same arguments. We're going to get the same result back, probably. And so the arguments that this inner function needs to take are the same arguments that my function would take. So let's start by keeping it simple, and let's just call our argument arg1, and I'll expand on that in a bit. So we're going to return arg1, or we're going to take arg1, and then when we call my memode function, that's when the normal stuff happens, right? That's when we want to call this function that we're passing in. So we do that, right? So what we have here is nothing. We've copied all of the functionality that we would have gotten by just calling my function directly, but in the series of wrappers. So let's double check that I didn't make a typo there. Let's see, I will, hopefully this will be easier to see. Okay, so let's make my function, and we will have that return foo. I'm live coding. What did I do wrong?
You didn't define my function.
Oops. Thank you. Okay. So now if I call it, we get back foo. My memode function cool, and we get back foo. So what we were hoping. Right now, our memoization wrapper is not doing anything. Okay, so let's make it do something. So the thing we're going to make it do is we're going to use closure to make a variable that is private to just this memoized enclosure. We don't have to do it this way, but it's a nice way to make it self-contained. It's a nice way to make a memoization process into a pure function. So we're going to create a variable here. And I guess I could use let, but yeah, I'm not. So we're going to make a map. So saved args is equal to just an object. Okay. So as we're doing this, saved args is now available to absolutely nobody aside from this inner anonymous function here. Nobody can get at it, nobody can see it, nobody can mess with it. And so that's one of the reasons that it makes this into a pure function. And so then in here, now we can do things with those saved args before or after we call this f function. So for example, we could do something like if saved args has arg1 let's see. So if saved args does not yet have a value for arg1, whatever arg1 happens to be, we're going to add it. So we're going to say saved args arg1 is equal to f arg1. And then now, instead of calling it down here, we're just going to return saved args arg1. Questions about that? Okay, let's run it. See if I type out anything. So my function is still foo. So now I'm going to do another one. And so now if I call my memode function, I did typo something. Let's see. Let me refresh just to make sure. Okay. My memode function. Oops. Okay, yeah, I typoed something. Let's see. Oh, I want to make sure that it is undefined. So if it's not in saved args, we want to save it. Try that again. There we go. All right, so we're memoizing this argument foo, and at the moment that's not doing a whole lot for us. The whole kind of reason you would memoize something is to save on computation. So just returning a string is probably not a great use of that. Let's create something a little tricky. Let's see. We started a little bit late. Is everybody okay to go a few minutes over, 10, 15 minutes over? Okay. We're going to make a function called sleep. And sleep is going to do this. We're going to grab something called now, or we're going to grab a Unix timestamp is the variable now. Now we're going to do while now is, let's see if I can do this off the top of my head. While now is greater than or less than, I'm not sure. Let's see, plus time, so that'll put this in the future. Let's see, do I have that right? So the idea behind sleep is we don't run into this in the JavaScript world almost ever. Everything in the JavaScript ecosystem is set up to not block. And really the only time you run into blocking functions is when you happen to write a function that's doing something computationally expensive. And that's usually a surprise, right? Like you didn't realize it was going to be computationally expensive until you threw a huge data set at it, and it took a long time. So what we want is we want a simple function that's going to block the UI thread. And I've used this for testing a few times. So let's say I suck at Boolean logic. So if now is greater than or less than, let's find out. Okay, that wasn't it. There we go. Does it finish, or do I have a bug? I have a bug. Let's kill that. Let's see, can anybody spot my bug? Oop. So let's see, grab the current date as Unix timestamp plus additional time. So if we want it to sleep for 3 seconds, then date.now plus, 3 seconds. This is date.now. I'm expecting the while loop to spin for as long as this conditional is true. Yeah, let's cheat since we're on a time crunch. I've been here before. Let's see. Oh. It's less than, right. That looks better. Okay, let's try that.
Still need your less than sign.
Oops. Thank you. Ah, sweet. Okay. All right. We've got a sleep function. So I've used this before on more than one occasion to test things that are going to block the UI thread. Have you guys ever heard that mentioned, or have you ever actually seen it happen? I'll show you an example. Say, say we're on some website like .com. Okay, so on mx.com we've got these, right? Real simple. These are reacting to the mouse hovering, right? So if we run something computationally expensive, and our sleep is, it's technically computationally expensive, but you know, we're cheating. So say like we sleep for 5 seconds. So now the UI thread is blocked. Hover is not going to work, clicks are not going to work. The browser is essentially frozen. And so if you've ever heard somebody say you should avoid blocking the UI thread, this is a way to do that on purpose. Blocking the UI thread gets into JavaScript's event loop, which is how JavaScript works. It's how it does all of its asynchronous stuff. And that's why you have things like set timeout, request animation frame, to avoid blocking this thread. So there's only one thing that's doing all of this computation in JavaScript. And so if you do something that takes up all of the computation, absolutely nothing else can run. So that's what it means to block the UI thread. Any questions about that before we close this? Yeah. So now let's try this with, let's try to memoize our sleep and see if our memoizing does what we want it to. So memo sleep is going to be equal to memo sleep. Okay. So the thing that we're going to look for is the first time we call this memoed sleep. We should have that delay. So 1, 2, 3. There we go. So now the second time we run this, we should get it back immediately, and we do. So we've memoized that delay. So there's an example of where memoization might be important. And so we got into this by talking about Redux selectors, right? Where Redux selectors are automatically memoized with the application state. So if you have a selector that needs to do something expensive and you don't want to run it all of the time, this is where that memoization comes into place. So that memoization will save the last version of your application state so that when you run it again and that state hasn't changed, then the selector returns immediately. It returns that cached value. So the way we've set up our memoization function here is very specific to a function that takes a single argument. If you need to memoize something that could take more than one argument, you have to start to be very, very careful. So say like we wanted to take any number of args, right? And we're going to call our function with any number of args. How do we save that? We've got to change something here. We're storing those arguments as a key in an object, so we can't stuff an array as a key into an object. And so this is where Memoization is not like a single thing. Memoization is a technique that you use. And there's a variety of ways that you would memoize different kinds of functions. So if you know you're memoizing a React component, you might want to cache that. You might want to save that in a different way than you would say save a string argument or something like that. If you don't know what you're memoizing, one way to go about it is to do something like this. And that will work a lot of the time, but not all the time. So one of the things to watch out for with stringifying something via JSON is it's not stable. If you're stringifying an object, the keys are not necessarily sorted. And so you might want to sort the keys before you stringify it, which is a whole other pain in the butt. Now, often the keys will be stable, especially on the same machine. They might not be stable across machines, but they're not guaranteed to be stable across the same machine either. It's just usually they are. So if you do something like this, just keep in mind little things like that. You need that value that you're using as that key to be as stable as possible. So anyway, this will work some of the time for some things. If you're memoizing something huge like a Redux state, for example, you might not want to go about it this way. You might want to do something else. You also don't need to save everything. So right now, this will grow unbounded. This cache, this saved args cache here, has no bound on it. Every time you call this memoized version of the function, it'll just keep appending stuff to it without limit. And so if you're doing that with something large, you might run into memory problems eventually. So maybe you want to say, only add things to this cache if they're bigger than a certain size. Only add things to the cache, and if the cache is bigger than a certain size, you drop something off before you add something new. So it always stays the same amount. Or there's the memo hook that has been added to React, and it just saves the last value, right? So if you call it twice in a row with the same value, that's memoized, but nothing else is. So that you would just do last seen arg, right? And then you don't have to check anything. You're just saying, well, I guess you check the last seen arg, but then you're just storing one of a thing. You're not storing an object of things. So any questions about kind of how open-ended that is?
So you were stringifying it so that you could compare.
I was stringifying it so that I could store it as a key in an object. So yeah, so that I could do saved args, argval, so that I know that that's a string. But I don't have to keep an object. I could keep an array of things. So maybe looking things up in an array, like doing an array.find. It's not as fast as looking things up in an object, but if this cache is bounded, if you're only looking at 100 items, you're only going to cache 100 different items. Maybe it's fast enough. Yeah.
That one doesn't have duplicates, right?
Yep. So it wouldn't have. Yep. So it would work. I've used a map as well for Ajax calls. On that note, let's try something fun. Let's see. I think this will work. Let's test it. So if I do this. Okay. Here we get back a bunch of user objects from the GitHub API. And you can see we made a network request. Sort of. Let's see. How do I hide this new thing? That wasn't it. Man, where is that? Okay. Yeah, so you can see I made a network request to the GitHub users API. So if I do that again, it's going to make another request, right? Every time I call that promise. So what happens if we memoize fetch? Okay. And so now instead of calling this, I'm going to call memoed fetch. Oop, that didn't memoed. Okay. So now if I call it, let's see, arg1. Oh, sorry, I left that incomplete apparently. There it is. Okay. Trying again. Remote fetch. There we go. So we got the network request. We got the results back. Now if we run this again, the stream is locked. Oh, I might not want to memoize that inner thing where I'm calling .json. I probably just want to memoize the result. Oh, I know. Let's see. No, that should still save the promise. Anyway, we can debug that at another time. This room is locked. Yeah, it's complaining about this inner call here. So we might want to do something like memoize everything up to this instead. Anyway. Okay, so before we call it, let's look at how we would use this technique to do things like Lodash has a function called once. And Lodash as once looks like this. Something like that. And the whole purpose of this is to guarantee that this function can only be called one time ever. So if it does some kind of initialization logic, or yeah, just anytime you only want to make sure that a function is called one time ever, you can use this the same technique, right? We don't need to change much at all. And there's our once. Is that clear enough? Want to test it, see if I type out anything. Let's see, didn't I have a, what do I call that? Yeah. Let's see. I missed something. Actually, we could just do this. Hmm?
You're never setting what's called true.
Oh, thank you. Let's see. That's kind of what I had before. I'm still missing something, aren't I?
Yeah, every time we call it, what's called is being set false, right?
This should happen one time. So when we get this function back, this will happen, and then it's done. So this is kind of like initialization logic. Of course, we can always verify that. So it's equal to false. Set it to true. Return the function. Otherwise,
If you call the function again, we're expecting no console upgrade.
yeah. Yeah, no, I'm expecting no what's called. It should just return undefined.
Try again.
You think I just have a cache problem? Oh, I did. Thank you. So, yeah. All right. This is kind of an interesting way to encapsulate data in a function. So we're using this technique to decide whether or not to call a function. But you can use the same technique to just hide data if you want. If you want to say, this is definitely private. There's no, Python's consenting adults, like only modify this internal variable if, you absolutely know what you're doing, kind of a thing. This is saying, don't touch this, period, at all, because you can't, right? So that was called variable is available to absolutely nobody. So if you ever want to completely hide data from being messed with, this is a nice way to go about it. So that's how Lodash does once. Let's talk about debounce, and then we'll call it. So with debounce, we're doing again this exact same pattern. Just the only difference is what our logic is for this this cached variable. So let's see. And debounce can get pretty complicated. What we're about to write is decidedly a simpler version of debounce. In fact, this might even be throttle, not debounce. So in here, we're going to say and then we're going to say if now plus time, let's see, I'll circle back to that as I think through it. So only call our function. So the goal with throttle is is if you call this function repeatedly within a short time frame, you're only going to get one invocation of that function within the kind of time frame. So if we say function 3000, then this function can't be called more often than once every 3 seconds. That's it. So back to our logic. So every time this function is called, we check the now. We see if now plus let's see, what do we want here? Is greater than, let's see. Let me walk through the logic. When we call this function, we want to see if the current time, we forgot to do our last called. So we're calling it now. Last called.
Are you assigning last call to them instead of initializing last call?
So last called is initialized here. So it starts out as we haven't called it ever. And now we want to, whenever we call it, we want to update last called.
In 43, you're initializing.
Sorry, here?
43.
Yes, so let's say we start by initializing it to nothing. Whenever the function is called, we want to set it to now. It's being called now.
Yeah, you just want to reassign it, not greater than 30.
So the last call.
Oh, I had a var.
That's what you're saying.
Sorry, totally missed that. Thank you. Okay, so now we want to see if now minus, or I guess it would be last called minus now is greater than time. Does that sound right?
You want the last call assignment inside the if statement, correct?
That's a good question. Do we want it?
If it's actually run.
Yeah. Yeah, I think you're right about that. Thanks. So if we call it, let's see, what could we initialize this to so that we don't get undefined minus now? Maybe we default it to 1970, you know, the start of epoch, something like that. Let's see. Let's try it.
So in 44, isn't it supposed to be now minus last call? Because now is going to be a greater time than the previous call.
Let's see. Let's call it. Yeah, you're right. Thank you. And what is epoch? Come on, just give me epoch in epoch format. I give up. We'll grab 1999. So, think that'll work? So, in order to test this, we're going to we're going to console log it because the return value isn't going to tell us everything we need to know. So my fun is just going to log out whenever it was called. So now we're going to oh, I do. Oh no, I was scrolled up too far. Oh, thank you. Yeah. Okay. Okay. Nope. All right, that's not going to work. Hopefully that'll be close enough. Actually, let's do this. Gravy, what did I hit? Still no. Oh, I didn't. Thank you. Let's go with three seconds. All right. So we've written our own throttle. Questions? Do this. I know you guys were following along, but do this on your own a little bit. I'll post these code snippets in the channel. This technique of a function that returns a function can be used for so many things. Hiding variables, tracking state for whenever something is called. There's a whole branch of programming called aspect-oriented programming. And Lodash actually has a few of the aspect-oriented programming operators called before and after. So say like you've got a function, aspect-oriented programming never caught on. It was kind of a neat idea, but it never caught on. But the idea is, say you've got a function that does something, and you want to add logging to your function. Well, you don't want to modify your original function that does this thing to also do this thing and to do logging. And so what you do is you decorate it. This whole pattern is called function decoration. It's a big deal in Python. Function decorators even have syntactic sugar in the language. So you decorate the function so that something happens before the function is called, or something happens after the function is called. And in Lodash, that's before and after. And so you say, before you run this function, or after you run this function, also run my logging function. And so now you can keep your function just doing one thing, and your logging function doing something else. So yeah, it's kind of a neat little side road that didn't go anywhere in computer science. But yeah, it's there if you need it. Thanks for coming.